Now, it's all well and good that we can write formulas and we know valencies and we can write names when we've been given a formula, but what's the point of all of this? The reason that we've learned all of these things is that we want to do something called balancing equations. We want to look at chemical reactions. We want to know what we start with, and you guys all know that you start with reactants, and the reactants then undergo some or other chemical change to become products. There's something known as the conservation of mass or the conservation of matter, and that tells me that no matter is created nor is it destroyed. That means that whatever is a reactant has to be on the product side, and if it's on the product side, it must have been on the reactant side. And not just be there, but be in exactly the same amount. So let's see how we do that. Firstly, what is a balanced chemical equation? It is an abbreviated way of representing a chemical reaction. Reactants are on the left-hand side, and you put an arrow. You do not use an equal sign. It's not like a maths equation. You must use an arrow, and you then get your products on the right-hand side. The elements on the left have to be equal to the elements on the right, as I just said, and chemical reactions are going to form compounds. During a chemical reaction, no matter is created nor destroyed, and we call this conservation of matter. When you are writing a balanced equation, do not alter the correct formulae. Only adjust the big numbers in front of each formula. Now, we did this last year, so it really shouldn't be difficult. Write down the formulae of the reactants and the products, and then count the different atoms on the left and the right and compare them. And then make adjustments. You only write numbers in front of the formulae. So you can't just put in some little extra subscripts whenever you want to. You know, you wanted 2 Cl, so you put a little subscript 2 there. Anyway, let's look at a real example. On the left, I have got 1 calcium. On the right, I've got 1 calcium. On the left, I have got 2 chlorines, and on the right, I have got 2 chlorines. That is a balanced equation. What about these ones? They're a little bit more interesting than the one that worked out perfectly to start with. On the left, I have got 2 hydrogens. On the right, I've got 2 hydrogens. Yay! On the left, I've got 2 oxygens. On the right, I have got 1 oxygen. That is a problem. I put a big fat 2 in front over there. Counting again. 2 hydrogens on the left, 4 hydrogens on the right, 2 oxygens on the left, 2 oxygens on the right. I need to fix the hydrogen problem, so I'm going to put another 2 over there. Count again. 4 hydrogens on the left, 4 hydrogens on the right, 2 oxygens on the left, 2 oxygens on the right. That is now balanced. Calcium carbonate. We have got 1 calcium on the left, 1 calcium on the right, 1 carbon on the left, 1 carbon on the right, 3 oxygens on the left, 2 plus 1, 3 oxygens on the right. 1 hydrogen on the left, 2 hydrogens on the right. I put a 2 over there. 2 hydrogens on the left and 2 hydrogens on the right. 2 chlorines on the left, 2 chlorines on the right. Now that is a balanced equation.